Welcome to our deep dive into the world of sprockets. These essential components are the backbone of many mechanical systems, from bicycles to industrial machinery. But have you ever wondered how these small yet mighty parts are made? In today's video, we'll unravel the fascinating process behind sprocket manufacturing, exploring different methods and their impact on the longevity of these crucial sprockets. Stay tuned as we journey through the intricate world of sprocket production. Before we dive into the manufacturing methods, let's take a moment to appreciate the evolution of sprocket design. From rudimentary wooden gears to today's high-precision metal components, sprockets have come a long way. Their design has been influenced by centuries of innovation and the relentless pursuit of efficiency. In the early days, sprockets were simple wooden wheels with pegs used in basic machinery like water mills. These early designs laid the groundwork for more complex mechanisms, but they were far from perfect. The wooden pegs would wear out quickly, leading to frequent replacements and downtime. As industrialization took hold, the demand for more durable and efficient sprockets grew. Enter the age of metalworking. The introduction of cast iron and later steel revolutionized sprocket design. These materials offered greater strength and longevity, paving the way for more sophisticated machinery and applications. But the journey didn't stop there. Advances in technology and engineering led to the development of precision machining and forging techniques. These methods allowed for the creation of sprockets with intricate tooth profiles and exceptional durability, capable of withstanding high-stress environments. Today, sprocket design is a blend of art and science. Engineers use advanced software to model and simulate sprocket performance, ensuring optimal efficiency and longevity. Materials like carbon steel, stainless steel, and even advanced composites are chosen based on the specific needs of the application. As we move forward, the future of sprocket design looks promising. Innovations in materials science, manufacturing techniques, and digital design tools are pushing the boundaries of what's possible. The humble sprocket, once a simple wooden wheel, has evolved into a critical component that drives the machinery of our modern world. Now that we've explored the fascinating evolution of sprocket design, let's turn our attention to the manufacturing methods that bring these designs to life. Next up, we have manufacturing methods of sprockets. Whether you're designing machinery or just curious about the process, understanding how sprockets are made is crucial for ensuring optimal performance and longevity. So let's break it down and explore the various methods used to create these essential components. There are 5 basic manufacturing methods for manufacturing sprockets. These include casting, machining, stamping, sintering, and forging, each with its own pros and cons based on the application. Casting involves pouring molten metal into a mold to form the sprocket's shape. This method has been used for centuries and remains popular due to its versatility. It's a cost-effective method and great for creating complex shapes. But the downside? Cast sprockets can have inconsistent grain structures, leading to potential weaknesses, especially in the teeth. These inconsistencies can result in faster wear and tear, reducing longevity. This can be particularly problematic in high-stress applications where durability is paramount. Casting is cost-effective but can lead to inconsistent grain structures, which may affect durability. A close-up image of a cast sprocket focusing on its teeth profile. The sprocket is made from rugged cast metal with slightly uneven surfaces and rounded edges, typical of the casting process. The teeth are evenly spaced but show minor imperfections and a textured finish. Next, we have machining. Machining involves using tools to cut and shape the sprocket from a solid piece of metal. This method is known for its precision and accuracy. The precision is top-notch, which means the sprocket teeth are perfectly shaped and aligned. The downside? It's more expensive and time-consuming than casting, requiring advanced machinery and skilled operators. However, the precision of machined sprockets generally means they last longer and perform more reliably, making them a preferred choice for high-performance applications. Machined sprockets are crafted from high-quality metal with sharp, well-defined teeth that exhibit precision machining. The surface is smooth and polished, with visible machining marks, such as fine concentric lines. The teeth are evenly spaced and have a uniform, detailed shape. Machining offers precision, but at a higher cost, making it suitable for high-performance needs. Then there's stamping. Stamping involves pressing a sheet of metal into a mold to create the sprocket. This method is fast and efficient, making it ideal for mass production. However, stamped sprockets can suffer from inconsistencies, especially in the teeth alignment and sharpness. These inconsistencies can lead to quicker degradation over time, particularly in demanding applications where precision is key. Stamping sprocket is made of thin, uniform metal with smooth, rounded edges. The teeth are evenly spaced and have a precise, consistent shape. The metal surface will show minor tooling marks and a slightly reflective finish. Next up, the sintering process for sprockets. Sintering involves compressing powdered metal into a mold and then heating it to form a solid piece. This method is known for producing parts with very uniform properties. Sintered sprockets can have very uniform properties and are often used for high-precision applications. The downside? They can be brittle and may not handle heavy loads as well as machined sprockets. This brittleness can be a significant drawback in applications requiring high strength and durability. Sprockets made from sintered metal will have a fine grain texture and a matte finish typical of the powder metallurgy process. The teeth are precisely shaped and evenly spaced, with slight surface porosity visible on the edges. Sintering provides uniform properties but can be brittle, limiting its use in heavy load applications. Here's an interesting side note. I once led a small team of engineers at a sintered metal plant where we worked on improving the yield of various sintered sprockets and gears. We faced three key challenges. First, the mold. Small fissures would often develop in the metal media, which had a texture much like sand, leading to weak points in the final product. Next was heat treatment in the furnace. If the furnace setup wasn't ideal, or there were mechanical issues, it would prevent the heat from reaching equilibrium, resulting in uneven sintering and compromised quality. Finally, the transport of parts in their green state from the mold to the furnace. At this stage, the sprockets were extremely fragile, and any mishandling could lead to deformation or cracks before they even reached the sintering process. Each of these challenges taught us the importance of precision and care at every stage of production. Finally, there's forging. Forging involves heating the metal and then hammering it into shape. This ancient technique is still widely used today for its ability to produce incredibly strong and durable parts. Forged sprockets are incredibly strong and durable, with a very fine grain structure. The teeth are also highly resistant to wear, making forged sprockets ideal for heavy-duty applications. The downside? Forging is an expensive and labor-intensive process, making these sprockets pricier. However, the investment often pays off in terms of longevity and performance. Sprockets made from forged metal have a smooth and dense texture with well-defined, uniform teeth. The teeth edges are sharp, with visible flow lines and a polished finish indicative of the forging process. Forging delivers strength and durability, but is expensive and labor-intensive. Identifying which type of sprocket to use for your application depends on the load requirements, environmental conditions, and desired lifespan. Next up, we'll go deeper into casting sprockets. Now that we've reviewed the different manufacturing processes in producing sprockets, we are going to dig deeper into casting sprockets. As we stated earlier in this video, casting sprockets are created by pouring molten metal or other materials into a mold. This process allows for precise shapes and sizes, making it possible to customize sprockets for specific applications. Unlike machining or forging, casting is both efficient and cost-effective, especially when creating complex designs. One of the greatest advantages of cast sprockets is their adaptability. Depending on the material used, whether it's cast iron, cast steel, aluminum, or composite, these sprockets can meet a wide range of demands, from handling heavy loads to resisting corrosion in harsh environments. Let's dive into the different types of material and their impact on strength, durability, and reliability of sprockets. Looking for a tough, economical sprocket that can handle heavy loads and resist wear? Cast iron sprockets might be your ideal choice. Known for their excellent strength and wear-resistant properties, these sprockets are widely used in agricultural equipment, mining, and construction. However, cast iron has its downsides. It is prone to rust, and its rough surfaces can harbor bacteria and contaminants. To tackle these challenges, cast iron sprockets can be treated with protective coatings. For instance, galvanizing adds a layer of zinc to guard against rust. Powder coatings provide a durable polymer layer, while electroplating with metals like nickel or chromium enhances corrosion resistance and boosts strength. With these treatments, cast iron sprockets can deliver the reliability and durability you need in harsh environments, without compromising on performance. If your application demands a more robust sprocket, cast steel sprockets are an excellent choice. They offer all the benefits of cast iron sprockets, with the added advantage of supporting heavier loads. Cast steel sprockets are particularly well suited for abrasive or high-temperature environments, making them ideal for demanding applications. In corrosive conditions, these sprockets can be treated with protective coatings like galvanizing or powder coating to improve corrosion resistance and ensure long-term reliability. Now let's talk about the key advantages of cast steel sprockets. They're cost-effective, offering great value for heavy-duty needs compared to machined steel sprockets. They can be customized into complex shapes, perfect for specialized applications. They have excellent wear resistance, outlasting softer materials in abrasive conditions. With the right coating, they can handle corrosive environments with ease. And finally, they're tough, able to resist cracking and breaking under stress, even in high-impact situations. Overall, cast steel sprockets deliver durability, versatility, and reliability, making them a go-to solution for heavy load applications across various industries. Highlighting the difference and similarities between cast iron and cast steel sprockets, the cast iron sprocket features a dark, rugged surface with a coarse texture typical of cast iron, while the cast steel sprocket has a smoother, more refined finish with a slight metallic sheen. Both sprockets have evenly spaced teeth and central hubs. Whether you select cast iron or steel depends on your overall need for durability and strength. Cast aluminum sprockets are significantly lighter than steel or iron, making them perfect for applications where reducing weight is critical. They also have a natural resistance to corrosion, making them ideal for use in high moisture, salt water, or chemical environments. Additionally, they're excellent for food-grade applications where hygiene is crucial and corrosion resistance is a top priority. However, it's important to note that aluminum sprockets are temperature sensitive, which can affect their strength and performance in extreme conditions. Some of the best applications for cast aluminum sprockets include printing presses, light-duty robotics, fillers in food manufacturing, small boats, watercraft machinery, and equipment used near coastal areas. Cast plastic or composite sprockets are the perfect choice for applications where corrosion resistance, noise reduction, and lightweight design are critical. Let's explore where these sprockets are most commonly used. First, in the food and beverage industry, these sprockets excel in environments where hygiene and corrosion resistance are essential. You'll often find them in conveyor systems for food processing and bottling lines. Next, the pharmaceutical and medical industries rely on their non-reactive materials to meet strict hygiene standards. They're used in drug packaging equipment and conveyors for medical devices, ensuring safe and sterile operations. In the chemical processing sector, their resistance to corrosive substances makes them ideal for equipment exposed to cleaning agents or reactive chemicals, offering both durability and reliability. Moving on to electronics manufacturing, these sprockets shine due to their lightweight and non-conductive nature, preventing interference with sensitive electronic components. They're a go-to choice for robotic arms and conveyor systems in high-tech assembly lines. The textile industry benefits from their quiet operation and lightweight design, making them ideal for textile looms and fabric conveyors, where continuous processes demand efficiency and low maintenance. For light-duty material handling, cast plastic and composite sprockets are perfect for systems that prioritize precision and corrosion resistance over heavy loads, such as small conveyors and sorting systems. Even in marine applications, these sprockets perform exceptionally well, thanks to their resistance to saltwater corrosion. They're often found in small boats, watercraft machinery, and other equipment used in coastal environments. Finally, in automated machinery, their precision and noise reduction make them indispensable in light-duty robotics and automated sorting systems. While cast plastic or composite sprockets aren't designed for high-load or high-temperature applications, they're a versatile and reliable solution in industries where hygiene, chemical resistance, and quiet operation are priorities. For your next project, consider cast plastic or composite sprockets, where lightweight performance and corrosion resistance matter most. Now that we've seen how sprocket designs have evolved over the centuries and the different types of materials used, let's explore the versatility of sprockets in various applications. Sprockets are not just limited to industrial machinery, they play a crucial role in numerous fields, showcasing their adaptability and importance. First, let's talk about transportation. Sprockets are a fundamental component in bicycles and motorcycles. In bicycles, the chain and sprocket system translates the rider's pedaling into forward motion, allowing for efficient and smooth riding. Motorcycle sprockets, on the other hand, handle much higher forces, transmitting engine power to the wheels, ensuring speed and control. Next, we have the automotive industry. Sprockets are integral in car engines, particularly in the timing system. The timing sprocket ensures that the engine's valves open and close at the right times, synchronizing the camshaft and crankshaft to optimize engine performance. This precision is vital for the efficient operation of modern vehicles. Moving on to manufacturing. In factories, sprockets are used in conveyor systems to move products along the production line. These systems rely on the durability and reliability of sprockets to maintain a continuous flow of materials, reducing downtime and increasing productivity. Sprockets are also found in robotics, where they help in the precise movement and control of robotic arms and machinery. In agriculture, sprockets are essential components in various farming equipment. Tractors, harvesters, and other machinery use sprockets to transfer power and motion, enabling efficient tilling, planting, and harvesting. The rugged design of agricultural sprockets ensures they can withstand harsh environments and heavy use. Even in the world of entertainment, sprockets have their place. They are used in amusement park rides to ensure the smooth and safe operation of roller coasters and other attractions. The precision and reliability of sprockets are crucial in providing a thrilling yet secure experience for riders. As we've seen, sprockets are incredibly versatile, finding applications in various fields. Their adaptability, combined with advancements in design and manufacturing, ensures they remain a vital component in modern technology. From transportation to manufacturing, agriculture to entertainment, sprockets continue to drive innovation and efficiency. Now that we've explored the diverse applications of sprockets, let's complete this video by detailing fingerprint identification of sprockets in our final chapter. We can identify the type of sprocket by examining the fingerprints left by its manufacturing method, such as casting, forging, or machining. Determining whether a sprocket is cast involves analyzing several key characteristics unique to the casting process. First, check the surface finish. Cast sprockets often have a rough surface with small imperfections or a sand-like texture from the casting process. Run your finger across the sprocket. You might feel small bumps or irregularities. Next, look for parting lines on the sides of the sprocket. These lines, where the mold halves meet during casting, may be subtle, but are usually visible upon close inspection. You can also check for markings or identifiers indicating the sprocket was cast. These are often found on the back or edges of the sprocket. For a quick test, perform an auditory check by tapping the sprocket with a metal object. Cast sprockets typically produce a dull sound compared to the sharper ring of a machined or forged sprocket. Consider the sprocket's weight. When you lift it, cast sprockets often feel heavier due to the internal porosity of the material. Finally, if the sprocket is damaged or no longer usable, you can cut through a section. Cast materials reveal a granular internal structure, while forged metals have a more uniform grain pattern. In comparison, the cast sprocket features a rugged, coarse texture with minor surface imperfections, typical of the casting process. The forged sprocket, in contrast, has a smoother and denser surface with visible flow lines, indicating its strength and refinement from the forging process. Both sprockets share a similar overall shape, with evenly spaced teeth and a central hub. By using these methods, you can reliably determine whether a sprocket has been cast. Now that we've explored the versatility of sprockets in various applications, it's crucial to understand how to maintain and care for these essential components to ensure their longevity and optimal performance. Proper maintenance can significantly extend the life of your sprockets, whether they are used in bicycles, motorcycles, industrial machinery, or any other application. First and foremost, regular inspection is key. Periodically check your sprockets for signs of wear and tear. Look for any visible damage, such as worn teeth, cracks, or misalignment. Early detection of these issues can prevent more severe problems down the line. Lubrication is another critical aspect. Ensure that the sprockets and chains are adequately lubricated to reduce friction and wear. Use the appropriate type of lubricant for your specific application, whether it's for a bicycle, motorcycle, or industrial machinery. Proper lubrication not only extends the life of the sprockets, but also enhances overall performance. Cleaning your sprockets is also essential. Over time, dirt, debris, and grime can accumulate, leading to increased wear and tear. Use a brush and suitable cleaning agents to remove any buildup. For industrial applications, consider using compressed air or specialized cleaning equipment to ensure thorough cleaning. In addition to regular inspection, lubrication, and cleaning, it's crucial to ensure proper alignment. Misaligned sprockets can lead to uneven wear and reduced efficiency. Use appropriate tools and techniques to check and adjust the alignment of your sprockets and chains. For high-stress applications, consider using protective coatings or treatments. These can provide an additional layer of protection against wear, corrosion, and other environmental factors. Consult with a specialist to determine the best coating or treatment for your specific needs. Finally, don't overlook the importance of replacing worn-out sprockets. Even with proper maintenance, sprockets will eventually wear out and need replacement. Replace them promptly to maintain optimal performance and prevent damage to other components. By following these maintenance and care tips, you can ensure that your sprockets remain in excellent condition, providing reliable performance and longevity. Proper maintenance not only saves you time and money, but also enhances the efficiency and safety of your machinery and equipment. And there you have it, a comprehensive look at the various sprocket manufacturing methods and their impact on durability and performance. This concludes this video. Thanks for watching, and don't forget to hit that subscribe button for more engineering insights. Catch you next time.